In this video, as promised, we'll be taking a quick break from exploring new MongoDB features to talk about something called promises. Promises make it easy for us to manage our asynchronous code, and they were designed to solve many of the problems that we run into when using callbacks in our application. Now, you might be wondering, why now? Why learn about callbacks and use them for so long, only to replace them with promises? Promises actually build on the callback pattern, so it's necessary to understand how callbacks work and how we can use them before we'll be able to understand promises. Promises are nothing more than an enhancement for callbacks, making it a bit easier to manage our asynchronous code. The goal of this video is to give us our first exposure to promises to explore what they are and how they work. In the following videos, we'll actually integrate promises into our MongoDB code. For now though, I'm actually going to close this file down and we're going to move over to the playground directory. In here, we're going to create a brand new file, 8-promises.js, and in here, we're going to work with a promise example. Now, to really understand how promises work, it's best to compare and contrast them with the traditional callback pattern. Now, I have this file 4-callbacks from earlier in the class. If you don't have that or you don't have any content inside of there, that's okay. I'm actually going to be emptying this file out too and starting with a basic callback example. Then we'll see how we can do the exact same thing using promises. So to allow us to view these files side by side, what I'm going to do is double click this little file icon to close down the tree view. Then I'm going to split the editors side by side. I'll have callbacks over here on the left, and I'll have the promises file over here on the right. And we're going to spend the whole video just working with these two files. Let's get started with the callback example, then we'll convert it over to promises. What I'm going to do is create a new function, something like doWorkCallback, and we'll create doWorkPromise over in the promises file shortly. Now this is going to be a function that performs some sort of made-up asynchronous task. We're going to simulate a delay using setTimeout, and we'll do the same thing with promises just to explore the basic syntax, but don't worry, we will learn how to use promises in the real world shortly. We'll be using them for everything, including connecting to MongoDB to read, write, update, and delete our data. For now though, we have doWorkCallback, and we can go ahead and call that doWorkCallback. And the whole point of using the callback pattern is a way to allow the caller of doWorkCallback to get the results. So I provide a callback function, and this function runs when I have either the error or the result. So right here, the first argument is for the error, and the second argument is for the result. We've seen this pattern with all of our callback functions, including those from MongoDB. So from here, we can go ahead and do things with the error or the result. Before we do though, let's start filling out doWorkCallback. We know we're getting an argument passed in when the function is called. So up here, I will name that parameter, and it's typically called callback, though I could call it whatever I'd like. And down below, we'll start the process of simulating that asynchronous process. So right here, we'll be using setTimeout to get that done. We provide the function to run after the set amount of time and the amount of time we'd like to wait. I'll wait 2000 milliseconds, which is just 2 seconds. Now from here, the asynchronous task is complete, and we can signal to the caller that we either got an error or we got a result. We got the correct success data. Right here, we do that by calling callback with one of two arguments. If things went poorly, we provide just the first argument, and in this case, I could have a string like this is my error. The second argument would be undefined. We could set it to undefined by not providing it at all, or by explicitly setting it to undefined like we're seeing here. Either way would work. Now with the callback pattern, we have to put a little bit of conditional logic in here because this is the only function that runs. It runs for both failures and for successes. That means we use patterns like what we've seen plenty of times in the course. If there is an error, we want to run some special code. I'll be using return to stop the function execution, and I'll go ahead and use console.log to dump the error to the terminal. If there is no error, then we must have gotten a result, and down below we could go ahead and dump that to the terminal as well. So right here, we have a very basic example of the callback pattern, and we can go ahead and run this program before continuing on. In the terminal down below, I'll use cd:/playground to navigate over to that playground directory, and from here, we'll run our file. Node for callbacks.js. When we run it, what are we going to see? Well, after that 2-second delay, I would expect to see my error message, and that is exactly what I get right here. Now, if things went well, we could signify that by calling callback with a different set of arguments. Instead of providing the first, we would just provide the second. So right here, I can do something like callback, providing undefined, which would be the error value, and then for the second argument, providing those success results. Let's say in this case, we're getting an array of numbers back. I'll use 1, 4, and 7. Now, if I was to save the program and rerun things, we should see our numbers printing after 2 seconds, and down below, that's exactly what we're getting. Because result had a value down here, the error code didn't run, and we got our result printing. So this is the callback pattern we've seen plenty of times before. I wanted to work through it one more time, just so we had a side-by-side comparison between how the two different setups work. So with callbacks, we can see that the order we call the callback in is important, the first one being the error and the second being the result. And we can also see that down below, we add a little bit of conditional logic to figure out if things went well or if they went poorly. Now let's go ahead and do the same thing, but using the new Promises API. For the Promises example, we'll be starting off much the same way. I'm going to create a new constant called doWorkPromise, and I'll set this equal to a new promise. Now, to create a promise, we use the new operator with the promise constructor function. So we call it like this. Now, most of the time, we as Node developers, we're not going to be the ones creating promises. Typically, they'll be created by the libraries we use. As an example, when we use promises with MongoDB, we're not actually going to create new promises at all. All of that happens behind the scenes inside of the library itself. But to understand how promises work, it's essential to at least become familiar with this syntax. Now, when we call new promise, we provide to it just a single argument. That is a function, and we could make this an arrow function that would work just fine, though you could also use a standard function if you wanted to. This function gets called by the Promise API, and we get access to 2 arguments. We have first up, resolve, and second, we have reject. And we'll end up using both of these as we move through the process of completing our asynchronous task. Now for us, that task is still going to be just simulating a delay using setTimeout, so let's go ahead and get to it. Right here, setTimeout, passing in our function, and the amount of time we'd like to wait. Once again, I'll just wait 2 seconds. Now, when it's done, we are ready to signify that we've completed the asynchronous process. In the past, with the callback pattern, we would signify this by calling callback in one of 2 ways. I would provide that first argument if things failed, and I would provide the second argument if things succeeded. In our case, what we have are 2 separate functions. I have resolve and reject. If things went well and we got the result we were expecting, we call resolve. If things went poorly and we did not get the result we were expecting, we would call reject. So right here, we're going to see some clearer semantics when working with promises. It can be a bit difficult to easily figure out that this means success and this means failure because the order of arguments plays an important role. Over here, the name of the functions clearly signifies that. So what I'm going to do is use resolve to say that things went well. Now we can pass to resolve and to reject a single value. So as an example, if I was calling reject, I would pass in my error. If I was calling resolve, I would pass in my success information. In this case, since I am calling resolve, I'll pass in another array of numbers to signify that we got the results we were expecting. Right here, 7, 4, and 1. Perfect. So at this point, we actually have the promise created. It's going to wait those 2 seconds, then it's going to signify that things went well. The question is, what's the other half? What we have here is essentially equivalent to what we have here. How exactly, though, do we do something when the asynchronous process is complete? Down below, we do that by using various methods on doWorkPromise. promise. Now in this example, do work promise is the actual promise, and a promise is nothing more than an object with a few methods that we can access. Down below, let's go ahead and explore them. Do work promise dot, and the first method we're going to use is .then. .then allows us to register a function to run when things go well, so when resolve is called. Right here, we can set up that function, and we get access to the data the promise was resolved with via this first and only parameter. So right here, I can call that result, and result lines up with what we had over here called result. So this function only gets executed when things go well. Right here, I'm going to use console.log to print two things. First up, I will print success. Then as the second argument to console.log, I'll dump the result variable to the screen. Let's go ahead and run the program and see what we get. Down below, that's going to be node 8-promises.js. And when I execute it, we still wait those 2 seconds since promises help us maintain and manage our asynchronous code. And then after those 2 seconds are up, we got success and we got our data. Now things don't always go well if we're using promises to query the database. Maybe the network connection drops and we can't access the database server. In that case, we wouldn't call resolve. Instead, we would go ahead and call reject. Now reject is similar to resolve in the fact that it accepts just a single optional argument, and in this case, that would be the error. So that would be similar to what we would pass as the first argument to our callback function in the callback example. Right here, I'll go ahead and do just that. I'll print the message, things went wrong, perfect. Now, when we call reject, this function is not gonna run. Remember, this only runs if things go well. Right here, we can chain on another method call to the catch method, and this allows us to register a function to run when reject is called. So right here, what I'm going to do is pass in that function. We're going to get access to the error, and then we can go ahead and use it. So right here, I'm just going to dump it, console.log. First up, I will print error. Then I'll actually dump the variable value to the terminal. Now with this in place, let's go ahead and run the example once again from the terminal. We're going to wait our 2 seconds, and when the 2 seconds are up, we get things went wrong printing to the terminal. Now, right away, there are some clear advantages to working with promises. One is clearer semantics. It's easier to understand the intention of the code. So over here, we have resolve and reject. We have 2 separate functions we call, and that makes it easier to just parse this code and figure out what's going on. If resolve is called, we know things went well, and this is our data. If reject was called, we know that things went poorly, and this is the error. With the callback pattern, we just have the single function, which means we need to look at all calls to callback and then figure out which of the 2 arguments was provided, which is more error-prone and easier to run into issues with. The next benefit has to do with the setup we have for doing something when an asynchronous task is complete. With the callback pattern, we have just a single function. It's up to us, the developers, to determine whether or not an error occurred and run the correct code. We did that using the if statement up above. When we're working with promises, we have 2 separate functions, only one of which will ever run. Down below, for example, when reject was called, we got our error printing, which means that this function did indeed run, but we never got success printing, which means that this function never ran. So with promises, it's not up to us to add that conditional logic into place. We provide 2 separate functions, making it easier for us to manage our asynchronous tasks. One more advantage of working with promises is that it makes it easy to not mess up. And what I mean by that has to do with this function right here. In this function, we can call either resolve or reject. We can't call both, and we can't call one of them twice. I can't reject 2 times. Once either resolve or reject is called, the promise is done and its value or state can't change. So we can't change the error message by calling reject again, and I couldn't bring it from a failure to a success by calling resolve down below. There's nothing built into the callback pattern to prevent that. So over here, there's nothing to stop me from running this code and calling callback twice. Now, this doesn't make any sense at all because our asynchronous operation should have either worked or not worked. It shouldn't have had both occur. With promises, we don't have to worry about that, and let's go ahead and quickly prove it. Down below, what I'm going to do is try to call resolve. I'm going to call resolve, and I'm going to pass in some data, 2, 3, and 2. This call is not going to cause the program to crash, but it's going to have no effect on how the program runs. At this point, when reject is called, the promise stops looking for new calls to resolve or reject. Down below, I'll go ahead and run the program. We wait our 2 seconds and we get our error message. At no point do we see the success message with this data printing. Now, the same is true with trying to call the same method again. So for example, I can't call reject providing a new error. That's not going to work either. If I do go ahead and run the program for a final time, we're going to see that we only get the first error showing up. So with promises, there are rules enforced behind the scenes that makes it a bit easier to not mess up. So it makes it easier to get the desired behavior that we're looking for, and it makes it easier to squash those pesky asynchronous bugs. Now let's wrap up the video by talking about one of my favorite things with any new programming feature: vocabulary. So as we're using promises, we want to be able to discuss what's happening using terms that make sense for all of us. Now we're only going to introduce 3 new terms down below. I have a series of JavaScript comments that create a little visualization. So right here we have a promise. When we first create the promise is known as pending. So our promise is pending for the 2 seconds before resolve or reject is called. A promise is pending until either resolve or reject is executed. Now, if resolve is called, your promise is considered fulfilled. If reject is called, your promise is considered rejected. So in our case, I could say that I have a promise called doWorkPromise. It's pending for 2 seconds and then it's rejected. If I were to flip the switch on these comments and call resolve and comment out reject, I would say I have a doWorkPromise. It's pending for 2 seconds, then the promise is fulfilled. So it's important to just be familiar with these 3 terms as they're going to come up as we discuss promises. Now, this is just the beginning with our work on promises. You're probably wondering, what does this all look like in a real situation? Well, it's actually pretty similar to what we see right here. In the next video, you're going to learn how to use promises with MongoDB, since MongoDB has built-in support for them. We're going to talk about updating our documents, and we'll do so using promises. Now, I have more to say about other promise features, but we'll discuss those throughout the course as they become necessary. I'm excited to continue on. Let's go ahead and jump right in to the next video.